Okay, so, sorry, Wes, again, you said, what was your question again? I apologize.
Yeah, so, because in the first part, you, so, like, 8 negative x becomes like negative 8x, so, and it's like plus 8 though, so like, would it just like cancel out when
Okay.
it becomes negative? Like,
What math operation is going on between that 8 and that negative x?
like multiply?
Multiply. So what I'm multiplying is the coefficients, and it's not really written, but this is a negative 1x. So 8 times the negative 1, and then the x is kind of stuck on. So that becomes negative 8x. Down here, when we're checking negative stuff, I need to take stuff and distribute the negative to each one. Negative 1 to the x cubed is negative x cubed. Negative 1 times 8x becomes negative 8x. And again, Nora said, this guy, exactly the same thing, so it's odd.
But,
Yep.
so it doesn't have to be like the same as like the original one? It has to be-
Okay, for it to be odd, this is what needs to be true, is these guys. For it to be even, it's different. Okay, let's look at the next example on this page. Okay. First of all, I wanna know what this equation is. Aiden, how do I multiply this out? What is that expanded?
X squared plus 9.
Okay, let's,
Oh no, x squared, plus 9x. Or plus 3x.
okay. So, it is super, super common to try and expand that in your head and get x squared plus 9, which is wrong. And if you're not comfortable with it, write it out. X plus 3 times x plus 3, and then first times first, last times last, inside times inside, outside times outside. Whatever. That's what the word FOIL is. First times first, outside times outside, inside times inside, last times last. Whatever. Multiply all the dudes to each other. So that's what the function is. So Zara, what do I need to test to see if it's even? I'm gonna put a negative in where the x is. Okay, so Byron, how do I do negative 3 plus x times negative 3 plus x?
Is 4.
Okay, first times first is
Is x squared
positive or negative?
positive?
Positive, okay. Outside times outside,
That'd be negative 3x.
inside times inside,
Then,
another negative 3x, and last times last?
9.
9. Okay, so Maya is x squared minus 6x plus 9 does my original f of x, this, equal f of negative x?
No.
No, so it doesn't equal, so what does that mean?
We don't know if it's odd yet though. We have to check it
We
first.
just know that it's
Not
not
even.
even, correct?
Oh, wait, so you can't just expand it and then do that? Cause what I did is I expanded it first, then I did the negative x.
Okay, so
Cause that switches the equation completely.
it doesn't, but, so I think what you're saying is you did this with the expanded thing, negative x times negative x is positive x squared.
Oh, wait, yeah, oh, okay. No, never mind.
No, I mean, alright, so what she said was faster. She took that thing and put the negative x into that, which is fine. I'm okay with that. As long as you expanded this one correctly, that's cool. Still ends up not being even. Okay, then, Maya said, but that doesn't show that it's odd. What do we need to check to see if it's odd?
Negative f of x.
Negative of the whole function. So So I'm gonna do negative of my expanded thing.
Makes sense why when it's like.
So Dora, here it is expanded and with the negative out there. For it to be negative, does f of negative x equal negative f of x? Does this negative x squared minus 6x minus 9, does that equal this pink stuff? Or no. So is it odd? So what do we call it?
Neither.
It's neither, neither.
Is there another option or another on?
Nope. Even odd, not. Neither. Free spirit, wild and crazy. Yep.
So it's not like these parentheses left in the exponent is the point. It's just the only one we have to do.
Yep, if it's a lumpy thing inside that parentheses with an exponent on it, you're gonna have to do some stuff. Questions on any of this? How's it going, Simon? Peters? Okay? Alright. And I hate the last one, because the last one says absolute value. I don't really. Those aren't parentheses, they're,
Bracket. What bracket? It's the.
Just means that like a negative can exist and it's always gonna be positive.
yeah, it's basically distance. I'm 2 feet away. That's also 2 feet away, and this is 2 feet away, that's 2 feet away.
Never changes.
It's always gonna be positive. I'm 2 feet away from you, I'm 2 feet away from you, like, it's not, I'm negative 2 feet. No. So, if I put in 3, I get out 3. If I put in negative 3, I get out 3. So did it matter that this became a, no, so absolute value of whatever it is still gonna be that. So h of x does equal negative h of x, or sorry, h of negative x, so it's even. Question or you just?
Wait, sorry, I have a question.
Yes.
So, how did the negative x that you put in after doing negative x turn into positive x in the fraction?
It's absolute.
Absolute value, doesn't matter what goes in.
It's gonna be
It's, it's gonna have the same, I wanna use the word value, but we're
I have questions.
Yeah.
If it were to be like that, but the negative x was already there, then would it stay negative x or would it just also be?
it just, so this is why I don't like this one. You gotta kind of reason, what does absolute value mean? It doesn't matter what goes in, if it was positive or negative, the same outcome's gonna come out. I put in negative 5.3, okay, what comes out? 5.3. I put in positive 5.3, what comes out? 5.3.
But, like, that's, okay, that's if you put it in, but what if it's already there, like, if, instead of it being.
It would come, if whatever value went in would come out positive, and it's hard to show that and say that with a variable. So don't panic about it, guys. Just a heads up, the homework tonight is to finish through page 20. We should get through, hopefully, enough of these. There'll be exit cards next week, the second one is Thursday, which is the day before a quiz. This one might not go into the grade book, but it will, it is meant to give you some feedback before you take the quiz. Okay?
Wait, sorry.
Yeah, I'm not great updating the calendar, Mr. Carroll does that for me. Griffin? Anyway, yep,
When you publish the quiz scores?
I'm sorry,
When are you gonna publish the quiz scores?
they are published.
Oh, they are.
Okay,
I have a question.
check over the homework. Yes, what's your question?
So based on what we've done, because if much of the class did bad, what does that mean?
It means you guys need to step it up. No curves.
Is it like an MCPS policy or is it like for you guys?
It's more, you guys need to be, last year we taught a lot of algebra two. For the first month, you need to come in knowing algebra two. So, guys, if, there are some people that, like, some people definitely didn't do well. Some people got stickers on their paper, sticker is an A. So, if you didn't do well, I expect to see you here at lunch so that we can get whatever background stuff fixed, so that we can move forward. Yeah.
Are we gonna get like our quiz papers back? to see
Not
what we got
today,
wrong?
probably tomorrow. Yes, absolutely, you're gonna get your papers back so you can see what you got wrong. And for those of you who are unhappy with the score, Mr. Carlos and I still have to talk about how we want to manage this. But whatever the case, those of you who want to do some kind of retake, you really need to come in and do quiz corrections. Dante, get off the computer.
So when are you available during lunch? Like what's Wednesday?
So I had people, a lot of people in for helpers at lunch today. Bella was here, Alexandra was here helping. So lunch on Wednesdays in here. Tuesday and Thursday, Math Honor Society is in Mr. Melendez's room. So, just to remind you, lots of stuff is up on Canvas. If you go to the modules in Canvas, this top thing is all the reference stuff. The bottom link is videos that we're recording right now. But then here, it's the packet, blank, and the answer key for the pages that we've gone through so far. And then in here is every day what we've been doing. So yesterday was day 11. And it tells you we did even and odd symmetry, what it's like to look at it from a graph and algebraically. Here's a link to the notes that we had yesterday, a link to the YouTube stuff, and what the homework was, and then what's coming up. I haven't posted today's page yet, but it's coming. So if you know that you're going to be absent sometime or that you were absent, check this. Because if you come in the day after and say, I didn't know what to do, so I didn't do anything, no. You have resources, you were absent, check the pages. Like, it's a pain in the butt to keep all this stuff updated. You could at least check it. Okay, so here, looking at the graph. Yes, we were asking you to still be able to graph, even though we did even and odd yesterday. We're still checking that you can do the old stuff, because some of you didn't do so great on that quiz. Things that I want to make sure that you can still do. X greater than 2. Stuart, is that the right side or the left side?
It's the left side. No, it's the right side.
It's the right side, because numbers bigger than 2 are on the right. So that's this batch. If you don't know how to plot coordinates, we're picking a 2 to start with, even though there's not an equal sign there. Because 2.00001 is a number that I could pick. It's too hard to use that number, so I'm going to pick 2 itself, and I'm going to plot that coordinate 1, 2, 1, 2, 3, 4, 5. I'm going to plot that coordinate, and I'm going to make it open. Virginia, why is it open, not solid? Because I don't have an equal sign on it. And then you guys could use your knowledge of geometry to be like, okay, I know it's a straight line because it's an x to the first, the slope is a 2, the number attached to the x. So from here go up 2 over 1, up 2 over 1. Or I could have plugged in another coordinate that's bigger than 2, like 4. 4 times 2 is 8, plus 1 is 9. So I could plot those dots, yeah. I skipped 3, but, oh, never mind. And then, yes, Dora.
So you can pick
two as the X value, even though it says bigger than two?
Yes, because I want 2.001 to be included, that's part of it, like, why do I have to start at 3, which is what you guys would probably do? There's a whole lot of numbers between 2 and 3 that are also bigger than 2, right?
Yeah, okay.
So I'm gonna pick 2 and leave that that circle open to be like, you know, plugging in 2.01 is too much pain. I'm gonna plug in 2 and just leave it open and go from there.
Okay.
Going to the other side, plugging in to here, the y value that comes out is -2, so going over to 2, -2, and then the slope, back 1, up 1, I get that line. I mean, what kind of discontinuity is this?
Jump.
Jump. Why is it jump?
Because you have 2 lines.
Okay, because 2 lines, 2 straight lines that go meet at different heights. The limit from the left was -2, the limit from the right was +5. They ain't the same number, that's a jump. Sarah, question, or are you just?
I just have a question. Why would it be X approaches 2?
What X value does the jump, this break happen?
Okay, so that's why.
Yep. We can look at it in the piecewise definition. I said for X values on this side of 2 and X values on that other side of 2, that's a hint that the problem's gonna be at 2. Or looking here on my graph, it's where the bridge broke, right? Also at 2. Okay, here is the work for the even odd checks at the bottom. The first one is odd, the second one is even, and the last one is even. And this is the kind of thing that we're expecting to see on exit cards, quizzes, and tests when we say, show it. And one of the things that you've gotta go all the way through, this statement, because this, I know it's odd. Because this, I know it's even. Because neither of those things worked, I know that h of x does not have any kind of symmetry. Griffin, good? Questions? Kinda fast, but it was, supposedly you guys did the homework. People had stuff written. I don't know if you had enough stuff written, they didn't check it for accuracy. Wes, you good?
Yeah.
Not calling you out or anything, just, okay, can we do the next things? Cause I wanna get you guys through stuff. Without graphing, can you guys do those limits quickly? I'm gonna set a timer for like 2 minutes.
Probably not.
Give it a go. 2 minutes, 2 minutes.
What's the middle piece, right?
What is the middle piece?
Yeah, what is, how does that one work?
It's
So,
a fourth, no matter what x is, if x is 2.1, 3.7.
okay, that's, it's just saying it has to be between 2 and 4.
When x is between 2 and 4, the y value is always 4, 4, 4, 4. You're like, well, what if it was 3.1? 4. What if it was 3.7? 4. Teddy to do 2 from the left, do I use the top, the middle, or the bottom?
I use the top.
Top, so plugging in 2 to the top, what do I get? 4. Dora, 2 from the right, top, middle, or bottom? Top?
No.
Numbers to the right of 2, is 0 to the right of 2.
I mean, regardless, I would still give you the same answer.
Sorry, what?
Regardless, I would still.
We will get the same answer, however, what we're plugging into is the middle. The right side of 2, numbers on the right, is 3 to the right of 2? Yeah. So I'm gonna put in a 3, for example. But Nora's right, we're gonna get 4 out. Antoinette, when it's equal to 2, do I have an equal sign on any of these? Do I have an equal sign on any of these for when x is 2? There's an equal sign under that symbol. So we're gonna use this top equation. Stuart, what kind of discontinuity do I have?
Or I think it's continuous.
Sophia, he thinks it's continuous. Do you agree?
Yeah.
Because?
It's continuous because f of 2 is still 4.
Because
So
the
it
left and the
exists.
right, and at that point, all the same y value. Yahoo. Anya, 4 from the left. 4 from the left. Do we use the top, bottom, or the middle to calculate that value? The left side of 4. Is this the left side of 4, or is this the left side of 4? What whole number is immediately to the left of 4? Yeah, 3. So is 3 less than 4, or is 3 greater than 4?
Those are the middle one.
There you go. So using the middle one, we get a 4. Nasia? The other side of 4. Okay, this is the side that's bigger than 4. Plugging 4 in for x, what number do we get? 9. Simon, add 4. Do we have an equal sign on any of them? No equal sign on either of these 4s? Yeah, which one? So what's the value when we plug that in? It's 9. Okay. Maya, what kind of discontinuity? Jump. Why is it jump? Well, because 4 doesn't equal 9. Limit from the left doesn't equal limit from the right. Yes?
Why on the first one, when this is coming from the numbers less than 4? Why do we need it?
Okay. What number is immediately, whole number is immediately to the left of 4? 3. Is 3 less than 4, or is 3 greater than 4? Less. So which one made it true? This one is what made it true. So we use that one. Okay? Okay, I need to get us to this page. We need to do at least one of these examples. So here, I'm gonna force the function to be continuous. I want it to be smooth and continuous. To be continuous, I need 3 conditions to be true. Joseph, what is one of the conditions that needs to be checked to see if it's continuous?
They have the same y.
Okay, so who's they?
One's to the left and to the right.
Okay. I need to test 2 from the left, 2 from the right, and the function at 2. Alright. Ella, which piece is to the left, the top or the bottom?
Top.
The top. Okay, so, Griffin, plugging into to the top equation, what number comes out? 5. Okay, from the right, Dante, the right is the bottom equation. Plugging in 2 for x, and x only, what comes out?
-6.
What do I do with this plus a? It's still there. It's the thing I need to figure out. What is the value of that a gotta be so that they glue together? Okay? Bella, do I have somewhere that's equal when x is equal to 2?
Yes.
What, 5? Okay. To be continuous, all of these have to be the same value. These guys already are the same value. How do I find Lippy?
We're just maybe 11.
Okay. So to be continuous, I need these two to be equal. And so Liffy added 6 to both sides and said, well, if A is 11, all 3 pieces are gonna glue together. That's what we need to do. Peter, how you doing? Can you see the board at all?
Not really.
Okay. Raul, you might wanna actually move back to this so you could see the board.
Oh, yes.
I'm sorry, I'll fix this even for tomorrow. Angel, how you doing? Okay, you guys try and set this one up. Number 2. Yep. I would need to see work. So the work that I was looking for on that. So you had all that stuff on there. I would wanna see, that was the left side and the function had the value of 5. The other side was -6 plus a. I wanna see that step. You didn't show it.
Oh.
So show me that you're setting the left equal to the right, and then you got the right answer of A as well. But I wanna see the work. Yes, Dante, what's up?
For the second one, what these two come out? Okay.
They become numbers. Yes.
19.
Okay, guys, please finish page 18, 19, and 20. Sorry, you've got an extra page.